Hi girls, let's talk about graphs of relations on page 14 of our notice. So we're talking about relations. Now every set of ordered pairs, either listed or graphed, is a relation, except some of those relations can be functions, in that when you take a set of ordered pairs and you graph them and draw a vertical line through the graph, if it only goes through one spot, then that relation is a function. We're talking about relations here that aren't functions, and the classic one is a circle. If you were to take a circle and draw a vertical line through it, it would go through two places at the same time, or it would go through two places. It's not a function, it's just a relation. And without saying where we get this from, all you have to know is that the equation of a circle with center AB and a radius of r is given by this equation. X minus a in bracket squared plus y minus b squared is equal to r squared. That's all we need to do. That is the equation for a circle with center AB and radius a. So using that, how about we go to this first example, sketch these graphs of the following circles. So we're told they're circles. How do we know? Well, we've got a x squared term, and then added to that a y squared term, and it equals something. So from that we can work out what the center and radius is and state a domain and range. So this one, x squared plus in brackets y minus 3 squared equals 1, would look better if I change my x squared into, in brackets, x minus 0 squared. Agree? And keep the y minus 3 squared, and that would equal 1. So putting in that form, I can say straight away that the center of this circle is going to be 0, 3. Comparing it to the equation at the top, okay, I've got x minus something, I've got y minus something, x minus something is 0, that y minus something is 3, the center is 0, 3. And the radius, oops, excuse me, and the radius would be, okay, so that's supposed to equal r squared according to the formula. So in this case, the radius would be the square root of 1, which would be 1. We won't worry about the negative version at the moment. So let's sketch this graph and then use that to state the domain and range. Okay, here's my best attempt at a circle with center 0, 3, that went there, and a radius of 1. Okay, what's its domain and range? So the domain, of course, are all its x values. So they would range between one more than x is equal to 0 and one less than x is equal to 0. Remember, 0 is the x coordinate of my center, and it's a radius of 1, so it's 1 more than 0, it's 1 less than 0. So my domain in this case will range between -1, this is all the x values I'm talking about for this circle, would range between -1 and 1. That is a radius of 1, or a distance of 1 from x is equal to 0, 1 less, 1 more than x is equal to 0. The range, on the other hand, would be based around 3. So when we're talking about the center of the circle being a y value of 3, okay, and it's going to be a radius of 1, so it's going to be 1 more and 1 less around y is equal to 3. So my values of y will be between 1 less than 3, which is 2, and 1 more than 3, which will be 4. The domain is x values between -1 and 1 included, and the range is y values between 2 and 4 also included. All right, the next one. We've got x plus 3 squared plus y plus 2 squared is equal to 9. Now, if we compare that against the equation for our circle, which is x minus a squared plus y minus b squared, and ab is the center, then if I go to x plus 3 squared and y plus 2 squared, I'm hoping you'll see that the center would have to be x is -3 and y is -2. And the radius would be the square root of 9, because remember, in the formula, it all equals r squared. We just want r. So we want the square root of 9, which will be 3. Again, this time we just want a distance, so we're not interested in the negative value of the square root of 9. Okay, so I've got a center of -3, -2, and a radius of 9. And again, here's my go at a circle with center -3, -2, and a radius of 3. So from that, again, can we work out the domain? Again, the domain over your x values. So this stage we're talking about the center having an x value of -3, and its a radius of 3. So our x values will range from between 3 less than -3 and 3 more than -3. So if you go 3 less than -3, you get down to an x value of -6. If you go 3 more than -3, you get to a value of 0. So the domain, our x values range between and include -6 and 0. So the range would be, or we'd start at -2, at y is equal to -2, which is the y value of the center of our circle. So our range would be, taking y is equal to -2 and the radius being 3, it would be 3 more than -2 and 3 less than -2. 3 less than -2 would give us -5. And 3 more than -2 would be 1. So our range, our y values range, will go between -5 and 1 included. All right. So if you were to take a circle and just break it up into half a circle, of course you'd have a semicircle. And the thing is, a circle is not a function. When you draw a vertical line, it'll go through 2 places, so it won't be a function. But if you take a semicircle, that is a top and a bottom portion, not side versions, but a top and a bottom version, and split it in 2, then you have an actual function. What do I mean? Let's go to the next example. It says, well, we're talking about semicircles. Sketch the graph of y is equal to square root of 4 minus x squared. Okay, so if we're talking about y is equal to the square root of 4 minus x squared. Okay, if I was to square both sides, I'd get y squared is equal to 4 minus x squared, yeah? And if I was to move the x squared from the right-hand side to the left-hand side by adding x squared to both sides, I'd get this. Y squared plus x squared is equal to 4. Now, what does y squared plus x squared equal to 4 look like? Well, that's a circle, of course, with center 0, 0, and a radius of square root of 4, which is 2. Yeah, we'd all recognize that. But when I take my y squared, so I'm going to go reverse now. When I go back to putting y squared by itself, y squared would be equal to 4 minus x squared, which we just did. And if you find the square root of both sides, y would be equal to the square root of 4 minus x squared. However, when you get the square root of something, you get plus or minus. Now in this case, we're only interested in the plus version of y is equal to the square root of 4 minus x squared. So what does y is equal to plus the square root of 4 minus x squared look like? Well, it's a semicircle. It's half the circle. When you put the 2 semicircles together, you get y is equal to plus or minus the square root of 4 minus x squared. The plus version would be above the x-axis. The minus version would be below the x-axis. But if you just wanted to graph y is equal to plus the square root of 4 minus x squared and identify its domain and range, it would look something like this. So this is my very best attempt at drawing a circle with center 0, 0 and a radius of 2. And it looks like this. Except we don't want a circle, we want a semicircle. We want just the top version, which will be y is equal to plus the square root of 4 minus x squared. Once I take the equation for the circle, y squared plus x squared plus is equal to 4, and rearrange it to get y squared, and then square it to get y by itself, I would have a plus or minus version. That would make up both arms. But if I only just want the plus version, this one here, not the minus version, then I don't need the bottom bit. I just need the top. And that is y is equal to plus the square root of 4 minus x squared. Plus. Okay, so what about the domain and range for that sucker? So the domain, again, of course, is the values of x, and as you will see, it ranges between -2 and 2. So domain is between, our x values between -2 and 2, and our range, our y values, they'll do the same. They'll range between a low of -2 and a high of 2. Okay, what about next bit, B? For the circle with equation 9x squared plus 9y squared is equal to 1, determine the equation of its lower semicircle, identify its domain and range. Alright, so we're starting with a circle. This one. 9x squared plus 9. Try it again. 9x squared plus 9y squared is equal to 1. Okay, now it would look better just as x squared and y squared. So if I divide everything by 9, I'd get x squared plus y squared would equal to 1/9. Now we can see it's got a center of 0, 0, it being a circle, and a radius of the square root of 9. So that is a circle, because it looks like a circle, looks like the formula, with a center of 0, 0, and a radius equal to the square root of 1/9, which is 1/3. Again, for now, won't worry about the minus version of that. We just want that distance, which will be 1/3. It's got a radius of 1/3. Now, if I was to take that equation again of the circle x squared plus y squared equal to 1/9, and rearrange it to get y squared by itself, I'd get 1/9 minus x squared. And then if I found the square root of both sides, I'd get y is equal to the square root of 1/9 minus x squared. This time, when we find the square root of something, we have to realize that we would have plus and minus version. Now the plus version of the square root of 1/9 minus x squared represents one semicircle of my circle, and the minus version represents the other semicircle. The plus version represents the semicircle that would be above the x-axis, where y would be positive. The minus would be below the x-axis, where y would be negative. So what's the lower semicircle going to be? It's the one that has the negative version. So we are after the lower semicircle. That would be y is equal to negative the square root of 1/9 minus x squared. Okay, now I might just go up here and draw a quick circle. So up here now I've got a circle with a center 0, 0, center 0, 0, and it's got a radius of 1/3, so it'll come out to positive 1/3 on the x-axis and negative 1/3 on the x-axis. It'll go up to 1/3 on the y-axis and down to negative 1/3 on the y-axis. Now that's what this circle looks like, and we're only interested in the lower semicircle bit. Then we can ignore this top bit if we like, and just concentrate on the bottom, and from there work out what the domain would be. So the domain for the lower semicircle would be x values ranging between negative 1/3 and positive 1/3. And the range, the y values themselves would range between negative 1/3 and 1/3. There's the domain and range for the lower semicircle, the one which says y is negative the square root of 1/9 minus x squared. Alright, let's go back. Now by this stage we all know what y is equal to x squared looks like. It's a parabola with a turning point at 0, 0. It goes through the point 1, 1 and goes through the point negative 1. Negative 1, 1. On the right hand side of my sheet here, on the graph here, or on the page, I've got this graph y is equal to x squared. It's a function. If you were to draw a vertical line anywhere through that equation for y is equal to x squared, it'd only go through one point. It's a function. However, if you take y is equal to x squared and you reflect it in the line y is equal to x, on this graph that's represented by this red dotted line, y is equal to x. If you reflect y is equal to x squared in the line y is equal to x squared, you get this thing, which is not a function, but this function is called y squared is equal to x. At any point that's on the parabola y is equal to x squared, for example, negative 2, 4, when it's reflected in the line y is equal to x squared, x and y values swap over. So negative 2, 4 becomes 4, negative 2 in the graph of y squared is equal to x. Now, as it says in your noties, the function y squared is equal to x is not a function. If you draw a vertical line through that, guess what? You go through 2 points. So it's not a function. It's a relation, but not a function. It has, we say, an axis of symmetry along the x-axis. Know what I mean? There's the x-axis. And the portion above the x-axis looks exactly like the portion below the x-axis. It's, we say, a line of symmetry. Rub that off, that was so bad. Anyway, it's got a line of symmetry along the x-axis. That is, y squared is equal to x, is sometimes referred to as a sideways parabola. It has an axis of symmetry along the x-axis. Now, going on, as y squared is equal to x becomes y is equal to plus or minus x. So if I just find the square root of both sides, the square root of y squared would be y. The square root of x would be plus or minus the square root of x. Remember. So we would say that y squared is equal to x, like the circle before, is composed of 2 parts or 2 arms. One above the x-axis, which would be y is equal to positive the square root of x, and one that would be below the x-axis, which would be y is equal to negative the square root of x. Individually, these arms, now here's the thing, when you take the individual arms at a time, just like you did for the semicircles, each of them are functions. Because all of a sudden, if you draw a vertical line through just one of those arms, it only goes through one spot. So they are functions. However, the original relation, y squared is equal to x, is not a function. It's referred to as the square root function. Now we're going to play around with the square root function for a little while. Now I'm sure by this stage you would all remember with fondness what happens if you were to take a function, let's say y is equal to f of x, and do some transformations on it. For example, if I take f of x and I add h to it, add k to it. If I go plus k, what happens? Well, the whole function f of x gets shifted up, yes, by k. If I take the same function and I minus k, it shifts down by k. If I take a function f of x, but in brackets I do something with the k, with the x this time, like minus h. Okay, minus h, actually thinking intuitively, or opposite intuitively, moves it to the right by h. And similarly, if you go f of x, but then plus a h in brackets, that moves it to the left by h. And putting a constant out the front would make would change the shape of it as well. If a is positive, the shape basically bends towards the y-axis. If y becomes multiplied by negative of x, all of a sudden all the y values become negative, so it swaps over y values over x values, so they're swapped over. So thinking of that, what happens if I take those sort of transformations and do it to the square root function, like I have in this lovely shaded general equation here? Okay, y is equal to the square root of x. Okay, we have some idea what that looks like, but if I do things to it like plus k, or minus h inside the square root, or times by an a at the front, I'm going to change its shape and similar direction as well. Now, we refer to the point at which your function starts, your square root function starts, as the end point. In this example up here, both arms of y is equal to the square root of x, positive or negative, both start at the point 0, 0. So we refer to that 0, 0 as the end point. But if I take 0, 0 and I plus h to the function, or if I minus h inside the square root, or plus k, it's going to shift around. The end point will be at the point h, k. If a is positive, okay, it looks something like this. If A is positive, you're going to get an arm that reaches above the endpoint. So if A is positive, the endpoint is a minimum. What are you doing? Thank you. Minimum point. That means that the rest of the graph will start at the endpoint and stretch above it. If A is negative, okay, so all our values, X values, Y values rather, become swapped over top to bottom. So in that case, the endpoint is a maximum point, and everything that you draw after it is below that endpoint, that maximum endpoint. The domain, which is all your X values, range between H and infinity. H is your X coordinate of your endpoint, and all the everything else stretches off into the distance above that value. And we know that because if I was to take in the function y is equal to a in brackets, so in the square root of x minus h plus k, we know that the square root of x minus h, you can't have a negative value. You can't find the square root of a negative value. So x minus h must be greater than or equal to 0. And if x minus h must be greater than or equal to 0, x, if I put h on both sides, would have to be greater than or equal to h. Okay, so everything starts and finishes at the h value for your domain. H value is the x coordinate of the endpoint. Now, if A is positive, the range. So what do your y values range between? Well, they would range between k, which is the y coordinate of my endpoint, and positive infinity. K is included because I've got a square bracket. It doesn't quite reach positive infinity, so that's why it's got a curved bracket. If A is negative, so if A is negative, the value of A in their function is negative, then your y values would be negative. So what's the range look like then? Well, that means you're going to start with hk and everything will range below that point. So all your y values would stretch from negative infinity up to and including k, if the value of A is negative. Okay, we'll do some examples of these later to show how that's the case. Let's go to this example. Sketch y is equal to 2 in brackets x minus 1 plus 3. Identify its domain and range. Include any x-intercepts with their coordinates, if they have any. Sorry, include any axis-intercepts with their coordinates. That's if they have any. Let's do A. Okay, y is equal to the square root of sorry, I was on the wrong page for a moment. We're back. Okay, so I've got this. Y is equal to 2 square root of x minus 1 plus 3. From that, I can identify the endpoint. The endpoint would be 1, 3. So already I can draw something that looks like that, which I will in a moment, but I'm trying to think. Do I need some room? Okay, what about any y-intercept? Will it cross the y-axis? What do we know at the y-intercept? X is equal to 0. So therefore, it would become y is equal to 2, x is 0. So it would become in the square root of negative 1 plus 3. Agree with that? X is 0, so it would become 2 square root of negative 1 plus 3. Do I need to go any further? That's not possible. You can't find the square root of negative 1. It's not possible. So what does that mean? It means that there are no y-intercepts. It doesn't cross the y-axis. What about x-intercept? What do we know at the x-intercept? At the x-intercept, we know that y is equal to 0. So then if I go back to my original, I'm trying to solve this. 0 is equal to 2 square root of x minus 1 plus 3. Now, if I rearrange that, I'll get I'll take the 3 on the other side to make it negative 3, and then divide it both sides by 2. I'll get negative 3 on 2 is equal to the square root of x minus 1. Do I need to go any further? Can you find the square root of anything and make it equal to a negative value, like negative 3 on 2 or negative 1.5? No, that's not possible. You can't do it. You can't find the square root of anything and make it equal to a negative power or negative term. So that means that there's no x-intercept as well. It doesn't cross the x-axis. It doesn't cross the y-axis. It doesn't cross the x-axis. What does it do? Well, here's my graph with the point 1, 3, which is my endpoint for my graph I'm about to do. And the rest of it just looks like this. Avoids the x-axis and the y-axis, doesn't cross them, but it just hooks up that away with an arrow on the end to indicate that it just keeps on going forever. That's the graph of y is equal to 2 times the square root of x minus 1 plus 3, with the endpoint at 1, 3. Is there anything else? Identify its domain and range, including x-intercepts. Well, there are no x-intercepts. What's the domain and range of this thing? Domain. All our x values. So our x values start at 1, do they not? And they end up at positive infinity. So here, in this case, our x values are between 1 and positive infinity. So I'm just going to say x values are greater than or equal to 1. That's all we have to say. What about our range? Well, our range starts at a y value of 3 and then goes upwards. So this arrow indicates that it goes all the way up to positive infinity again. So in this case, all our y values are greater than or equal to 3. Starting at 3, going all the way up to infinity. Part B says this, for the function fx is equal to the square root of 4 minus x, identify its domain, sketch the graph y is equal to f of x. So they don't want range, just want domain. That's sad. Okay, so we've got y is equal to the square root of 4 minus x. I'm just going to slap a plus 0 in there. It doesn't change it, but it will help us work out what the endpoint would be. Now, if I compare that to the shaded version at the top here, the general equation of the square root, I've got in the square root x minus h. This time I've got a h minus x the other way around. So I don't like this for a start. So I'm going to do a subtle little change and make this into the square root of, okay, I'm going to just factorize this. Take a negative out. If I take a negative out, 4 would become negative 4 and negative x would become plain old x. So I'd end up with negative x minus 4 and the square root of, and I've still got a plus 0 there. But by doing it this way, I can recognize what the endpoint would be, because now I can compare it to this version of the general equation at the top. So there's a negative at the front, but it doesn't matter. The endpoint, I can still say, is going to be 4, 0. 4, 0. Okay, let's find some intercepts. Shall we start with let's start with the y-intercept? Let's start with the y-intercept. What do we know at the y-intercept? X is equal to 0. So what does that mean? So that becomes y is equal to square root of 4 minus 0, which is just 4, plus 0. It just means that y is equal to 4. Now, what's the square root of 4? That is 2. Crosses the y-axis at 2. What about the x-intercept? Y is equal to 0. Okay, so now it becomes 0 is equal to the square root of 4 minus x plus 0. Okay, now to get x I need to find the square root of both those sides first. So the square root of 0 would just be 0. Square root of the square root, so the square of 4 minus x would be 4 minus x. Now 4 minus x would equal 0. What does x have to be? X has to be equal to 4. So that means across the x-axis at 4 and across the y-axis at 2. 2, starting at the endpoint of 4, 0. What does that look like? Oh, I know where the endpoint is. It's at 4, 0. 4 along the x-axis, 0. 4, 0. That is 4, 0. That's my endpoint. Now, it doesn't cross, well, and that tells us that across the x-axis at 4, its x-intercept is at 4. So the x-intercept and the endpoint, same thing. But it does cross the y-axis at 2. Now how does it do that? Start at 4, 0 and cross the y-axis at 2. Well, to do that, it's got to look like this. So that's what the function y is equal to the square root of 4 minus x looks like. Starting at 4, 0, crossing the y-axis at 2. Alright, that will do us for today, girls. Hope you enjoyed that and you're able to use this video to fill in your noties on page 14 and 15 now on graphs of relations. Alright, thanks for listening, girls. See you later.